We're moving on to the next question, which comes from trigonometry. So this one was sent to us by Matsiriso. Mbali gives you ideas of how to send questions. So listen to what she's saying and do exactly as she says. By using our app, you can upload and send the question directly to us. So thank you for those who have sent the questions. The next one is sent by Matsiriso Maferega. Let's look at it. So it's a trig question. It's an awesome question. Trigonometry is my favorite topic amongst a whole lot of my favorites. In fact, I feel like every time I get to a particular topic, I just get excited and I start saying it's my favorite topic. But this one is absolutely one of the nice topics. So we are given a diagram there. This question says, in the diagram, point P with coordinates k and 1. Okay, there's point P. The coordinates are k and 1, right? Is a point on the second quadrant and is square root 5 units from the origin R. All right, and R is a point on the positive x-axis, and obtuse angle ROP is theta. All right, question number 1, we are being asked to figure out the value of k. All right, now you should know by now that at the origin, we've got that the coordinates of the origin are O and O. You can just simply reverse the distance formula if you want to figure out the length of OP. Think about it. According to what we know that the distance formula says the length of OP squared is just x at P minus x at O squared plus y at P minus y at the origin squared. Now, why am I doing this? I want people to know why we do what we do when we just say x squared plus y squared is r squared. Your x at O is 0, your y at O is also 0, so you just end up with x p squared plus y at p squared. I know most people, when they get this kind of a question, the first thing that comes in mind is that x squared plus y squared is equals to r squared. I just wanted to say to you, this is not new math. It's the same as what you'd be doing when you were looking for the distance formula. So we know that the length of this particular line OP is the square root of 5. We're going to need to square that. The x value is k, right, squared, and the y value is 1. Okay, so this is going to give us 5 minus 1. So you'll have this actually as your answer. According to this, k squared is 4. You take the square root on both sides. So if you just did this, you made a mistake. Remember, the square root, it has to be plus and minus. So the solution is just going to be k equals to plus or minus 2. We have to definitely take out the negative k value because of the positioning of that particular k. So k is going to be negative 2 because it's on the negative side of the x-axis. So k is equal to negative 2. Brilliant stuff. Right. Without using a calculator, work out the value of tan theta. Right. So we want to work out the value of tan theta. Now, if you think about it, we can construct here. Okay. And then we are basically looking for tan. By our trigonometric definitions, tan theta is just going to be y over r. So you guys should know this, y over r. So your y value is 1 and your r value is the square root of 5. So the answer to the tan theta is going to be not y over r, it's basically y over x. Remember, tan is opposite over adjacent, so it's y over x. So it's simply going to become 1, okay? It's going to become 1. I'm looking at the sign now. Okay, 1 over the x value, which is simply negative 2. If you put them here, it actually helps you. If I put a 1 here and I put a negative 2 here, it becomes easy for me to see what is going on because I'm then looking for y over x, opposite over adjacent. Then that's going to give me 1 divided by negative 2, which is just simply negative 1 over 2. The next question is asking for the cosine of 180 degrees plus theta. Cosine of 180 degrees plus theta, we can then obviously apply our knowledge of reduction formulae. What do we know about the reduction formulae? Well, we know that when anyone asks you for the cos of 180 degrees plus theta, you go and look in which quadrant is this angle that they're talking about. That angle is simply an angle that it would lie in the third quad if theta was an acute angle. So I can use the same idea and then say in that quadrant, cosine is going to be negative. So I'm going to have negative cosine of what? Of theta, because 180 plus would fall in the third quad if theta was an acute angle. All right? We're still using the same idea to try and solve for this particular problem. Now, according to our knowledge, cos, what is cos? Cos is simply x over r. Okay. okay, x over r. So that's simply going to become negative. My x value is negative 2, and my other value is actually the square root of 5. So if you simplify this further, you then end up with a solution of 2 over root 5. I don't know if they just said they want this, but you can rationalize and be nice. Be nice to people. Multiply by root 5. Over root 5, you get 2 root 5 divided by 5 as the solution to the value of cos 180 degrees plus theta. Right, I'm pressed for time, so I'm going to be quick and do this one of sine theta plus 60 degrees in the form a plus b divided by the square root of 20. So sine theta plus 60 degrees. So what I'm going to do now is I'm going to actually apply my knowledge of compound angles. You want sine of theta plus 60 degrees. Now remember, once you have these kinds of problems, you can then check in your information sheet if you ever forget the expansion of the compound of sine, right? So I know it. If you know it, it's easy to even identify it in your exams if the examiners are using these expansions. You're definitely going to get compound angles and double angles as a matriculant. So be careful of that. I'm looking at sine theta plus 60. I'm going to expand. Let's just see how it's going to look. So sine theta plus a plus b expands to sine theta cos of 60 plus cos of theta sine of 60. Right. Now cos of 60 and sine of 60, I'm not worried about them. They are special angles. I'm going to put them first. So cos of 60 is a half multiplied by the sine of theta plus sine of 60 is root 3 over 2 multiplied by the cos of theta. Right. Now I need to simplify this, but then remember sine theta and cos theta will come from the diagram. Half is a number. What is sine theta from the drawing? Sine theta is y over r, right? So it's going to be 1 divided by the square root of 5 because it is y over r, okay? So I'm going to have 1 over the square root of 5 plus square root 3 over 2, okay? And then we definitely have the cosine of theta. What's the cosine of theta? We did say that that's actually negative 2 over the square root of 5. That's what cos of theta is, since cos is x over r. Now we have to clean this up. 1 times 1 is 1. You get 2 root 5. Add this with negative times positive. We are simply going to get a negative solution. Let's go straight and put it as a minus. So 2 root 3 over 2 root 5. Okay? Okay, then of course we've got the same denominators. We can just simply take 1, 2 square root 5, and then on top we're going to have 1 minus 2 square root of 3. But the examiner was specific. They said they want the solution in the form a plus b over root 20. Was it even root 20? Let's go and check if it was root 20. Yes. Remember what they're asking for. Do what they're asking for. They want you to write it in the form something plus something else divided by the square root of 20. Now I must forge my denominator to be the square root of 20. It is currently not the square root of 20. So I'm going to reverse 2. I'll rewrite 2, okay, as the square root of 4, okay, times the square root of 5. The square root of 4 is 2. I actually didn't do much here, or I did nothing, because this number is the same as that number there. But once I'm done with this, I'm then going to use that law of surds that says the root of a times the root of b can be written as the root of a multiplied by b. Okay, so I'm going to just simply do that. I will rewrite this as 1 minus 2 square root of 3 divided by the square root of 4 times 5, which eventually leaves us with what we're looking for. 1 minus 2 root 3 over the square root of 20. Don't be bothered by the fact that the sign in the middle there is not a plus. It can be a minus. It's okay. There's nothing wrong with this. I can even put it as 1 plus negative 2 root 3 all over the square root of 20. And this will be the solution to that problem.